Batteries have steadily been getting better, but progress is slow. Rechargeable lithium-ion batteries still provide the best combination of compactness, power and efficiency for products ranging from drones to smartphones and cars. Research groups around the world are searching for more powerful batteries, but none, as yet, has ventured much beyond the laboratory. Sir James Dyson, a British inventor who makes vacuum cleaners, hand dryers and other electrical goods, says he is investing £2 billion, or $2.7 billion, to develop an electric car which will be powered by a novel solid-state battery. For decades, consumer electronics, your phone, computer, camera, tablet, drone and even watch have run on lithium-ion batteries, thanks to their easy rechargeability and high energy density. In these batteries, a lattice of graphite stuffed with lithium ions forms the anode. An oxide forms the cathode, connected to the opposite terminal, and the two are separated by a liquid electrolyte that allows ions to pass through it. When the external terminals are connected, the lithium oxidizes and the lithium ions flow to the cathode. Charging is just the reverse, and the more lithium ions that can be transferred this way, the more power a battery can hold. It's hard for scientists to find a material better than lithium from which to make a battery for use in portable devices and transport. Lithium is light, highly conductive, but inherently unstable. Manufacturing faults, damage and general wear and tear can lead to a short circuit through the electrolyte, causing the battery to overheat and even burst into flames. A solid-state lithium-ion battery would have a solid electrolyte and would be safer and more powerful. Such batteries, it has to be said, already exist, but they're usually small coin-sized cells that provide backup power in electrical circuits such as motherboards and computers. A number of groups are looking at ways to scale up the production of such cells so that it can be made into batteries that are sufficiently big and powerful to drive an electric car. The aim is to produce low-cost batteries with long and safe service lives, and crucially the energy density to greatly increase the range of a typical electric car. In the case of cars, batteries are ultimately responsible for the lifetime of the vehicle and for that dreaded range anxiety when it comes to electric cars. To tackle the problem, engineers and scientists are trying to cram more voltage capacity into batteries. But that's often associated with faults in chemical reactions, which diminishes the capacity over time. A great deal of research, therefore, is devoted to finding new materials and chemicals to assist or replace the lithium-ion lattice. An obvious question to ask, though, is perhaps lithium could be replaced entirely. Researchers are looking at ways to use sodium or magnesium instead, and magnesium is especially attractive because its structure allows it to accept 2 electrons per atom, doubling the charge it can hold. All this research is going to be influential to the batteries in our pockets and those in our cars. But there's a third category where the impacts are going to be just as global. These huge redox batteries will store power from renewable sources and release it when the wind doesn't blow or the sun doesn't shine. In a redox battery, energy storage materials are held in liquid form and in large tanks, then pumped into a smaller cell where they react with similar apparatus but has the opposite charge. These batteries will even out the peaks and valleys of energy production and consumption and will help renewables scale up to provide more than just supplementary power. Successfully commercializing solid-state battery technology could be key to making electric battery cars as affordable as today's gasoline cars. Experts say this means the cost of producing 1 kilowatt-hour of electricity needs to fall from the $200 per kilowatt-hour it costs today to around $90 to $100 per kilowatt-hour. Dyson has set an ambitious target, saying his electric car and new battery should be ready for the road in 2020. Toyota has a similar time frame in mind for the launch of a new electric car that will be powered by a solid-state lithium battery that it's also developing. Having commercially viable production techniques will be key. Existing lithium-ion batteries, like those being used in Elon Musk's new $5 billion gigafactory in Nevada for his Tesla electric cars, will continue making progress and will fall in cost. This means that the solid-state lithium battery has to overtake its more established rival by some margin, not only in terms of cost, but also in performance and reliability. If the new battery can do that, it would be a real breakthrough.